In the last video, we ended on this slide. I gave you 3 data sets, and I asked you to find the mean, median, and mode of each of the data sets. And I also asked you to find the range. Now we said the mean is equal to the median, which is equal to the mode, which is 7. So that described the center of the data. We also said that the range for each one of these data sets is 12. And that kind of gives us an idea of how things are spread. The smallest to the largest value, the distance between those values. But when we look at these data sets, they're quite different. The first data set has a lot of 7s. They have the number 7 was the mean, and we have it repeated several times, except for the first and the last values. While in the second data set, there were 5 7s, and in the third data set, there were 3 7s. And the differences between the 3 sets is, as we go down in the sets, things are a little more spread out. And this is not captured by the range. We need another number to describe how things are spread out internally, not just from the first number to the last number, but what's happening in the middle. And this is standard deviation. Standard deviation is a number that describes what's happening internally in these data sets. So let me tell you a little bit more about standard deviation. It's a mathematical way that describes how far the data are distributed from the mean. So I'm going to give you a number, and that number can be interpreted as, oh, the higher it is, the more things are spread out. And the smaller it is, the closer the data is to the mean. So standard deviation is always a number. We're going to use the letter S to represent standard deviation for a sample. So standard deviation is always a number greater than or equal to 0. If the number is equal to 0, that means all of the data is the same number. So if we just had a bunch of 7s, nothing else, then all of the data values are equal to the mean, and so the standard deviation is 0. That means there's no spread. Everything is the same. So the closer S is to 0, the less spread out the data is from the mean. Now, the bigger S gets, the more spread out the data is. So things are going away from the mean. So let's look at those 3 data sets again. Right now, I just want you to have an intuitive understanding of standard deviation. So I have these 3 sets, and we said that the mean for each one of them is 7. Now, which set is most similar to the mean? That is set 1. Which set is the least similar to the mean? Well, that's set 3. And set 2 is somewhere in between. So if I was to give these a number from 0 to infinity, as big as you can get, the closer to 0, the closer the data is to the mean. Let's see if we can rank them. Which one we would think has the smallest standard deviation, or the number that's the closest to 0, and which would have the largest standard deviation. So the first set, because most of the data is very similar to 7, would have the smallest standard deviation, while the third set would have the largest standard deviation. And set 2 would be somewhere in the middle. Now there's a formula to calculate standard deviation, and I'm going to show you that formula in a minute. And if you use the formula, these are the numbers you're going to get. You're going to get that set 1 has a standard deviation of 2.5, while set 2 has a standard deviation of 2.6. And I've highlighted this one in yellow because we're going to go through the formula for this particular set in a little bit. But right now, we're just going to look at the numbers. Set 3 has the highest standard deviation, which is 4.4. Now again, if set 1 was all 7s, the standard deviation would be 0. If set 1 was all 7s, but the first number was a 6 and the last number was an 8, 6 and 8 are just a unit away from 7. So the standard deviation would be close to 0. It wouldn't be 0, maybe it would be like 0.6 or 0.9, maybe 1, something like that. But you can see the numbers 1 and 13 are further away. So that's why this number is it's not big. 2.5 is kind of small, but it would be, it's bigger. The standard deviation is bigger than something like if I had all sevens, except for the first number being a 6 and the last number being an 8. So it's really, we're figuring out the distance from 7, the distance from 7 to 1, and the distance from 7 to 13. And the formula calculates that in. Okay, I'm going to show you how to actually calculate this by hand. On a test, I will not ask you to do this. I just want you to see it and have a little bit of an understanding of what standard deviation is. We will use a spreadsheet to actually calculate standard deviation. We will not be using the formula. Your goal is to understand like which sets intuitively would have a smaller standard deviation, which one would have the largest, and so on. And then like to see these numbers. If I said match these sets with the correct standard deviation, I gave you 2.5, 2.6, 4.4, you would be able to match them because you would know the first set has the smallest standard deviation because everything's very similar to 7, and the last one would have the largest standard deviation. So here's the formula for standard deviation. Now, this looks very complicated. I'm going to break it down a little bit and just work through an example. So remember that S, we're going to use the letter S to represent standard deviation when it comes to a sample. Now, it's common to use X bar. So you see in this formula, there's a X1 minus X bar. X bar is the mean for a sample. So that's the common notation for mean. And what this formula is saying is the first thing you want to do is find the mean. And you're going to take every data value and you're going to subtract the mean from it. So you see x1 minus x bar, x2 minus x bar. So in this data set, 1, 5, 6, 6, 7, 7, 7, 7, 8, 8, 9, 13, we would find the mean of this and we would take every number and subtract the mean. So let me show you what I mean. So the mean we said is 7 for this data set. And I'm going to take the very first data value, 1, and I'm going to subtract 7 and see what I get. I'm going to take 5, that's the next data value, and subtract 7. I'm going to take 6 and subtract 7, and so on. I'm going to find all of those numbers. And so what I'm doing is I'm seeing how far each piece of data is from the mean. And my formula is going to factor each piece of data in and calculate a number that tells me for each piece of data how far away we are. So here we've subtracted each piece of data, and that's the x1 minus x bar part, x2 minus x bar part, and so on. The next thing you can see we have squares. I'm going to take all of these subtractions that I've done, and I'm going to square each number. So so you see how I have -6 squared. Let me go back real quick. I have -6, and I'm going to square it. I have -2, and I'm going to square it. I have -1, and I'm going to square it, and so on. I'm going to square each one of these numbers, okay? So here's that second slide here, and you can see I've squared all of the numbers. Now in red, what I'm going to do, according to this formula, the inside of the square root says I'm going to add all of these numbers together. And if I add all of the numbers together, I end up with 84. And then the formula says I take in and subtract 1. In is the number of data values I have. And if you look at that set, if you count them, there are 13 data values. And I'm going to subtract 1 from that, and I'll get 12. So if I had a data set that had 20 values, I would take the mean, I'd find the mean for the whole data set, and then I would subtract every value. I would take the mean from every value, square all of them, add them together, and we said if we had 20 data values, we would divide by 20 minus 1, or 19. So in this particular example, I have 13 data values, I subtract 1, I get 12, and I take my sum of all these squares, I add them together, I got 84, I divide by 12, and I get 7. That's everything under the square root. Then the last step, now that red line is just repeated here. I'm going to take that 7 and I'm going to find the square root of it, and I get 2.6. If you recall, on those 3 slides when we were, on that slide where we were ranking the 3 sets from lowest to highest standard deviation, the one in the middle was 2.6. And oops, let me Sorry about that. I'm gonna copy this. There was a little bit of an error here. Let me just put it on the next slide. Okay. Sorry about that. So we are trying to find the sample deviation, standard deviation. There, that should fix that. Okay, so no more moving around. So we got to this point on the last slide. We said that we got the number 7 when we added everything up and divide by 12. Now on this slide, I just repeated that same thing, and now I'm finding the square root of that. And so we had 7. In this fancy formula we have at the top, we find the square root, and we get 2.6. So that is the standard deviation for this particular set, which matches the standard deviation that I gave you earlier in the video. All right, again, we will find standard deviation through a spreadsheet. But right now, my goal is just to make sure that you have an understanding, like an intuitive understanding of standard deviation. And remember, standard deviation is where we have a data set, we find the mean, and we are finding the difference between the mean and each value on the data set. And the closer the values are to the mean, the smaller the standard deviation will be. The further away the values are from the mean, the larger the standard deviation is going to be. So here I have the numbers 1 through 4. What I want you to do is I want you to pause the video and see if you can choose 6 numbers from the numbers 1 through 4. You can repeat numbers, like you could do 1, 1, 2, 2, 3, 3, or something like that. But choose 6 numbers where you can get the smallest possible standard deviation. You don't have to calculate it. You just want to try to do it mentally. What numbers can you create a set of 6 numbers that are very similar to the mean? All right, I'm going to show you 4 different possibilities. The set of all ones. The mean, if I average all these ones together, I would get 1. And they're all the same. All of the data values has a difference of 0 from the mean. If the mean is 1 and I take 1 minus 1, 1 minus, I get 0. And in that fancy formula I gave you, the standard deviation would be 0. That's the smallest standard deviation you can get. Same thing with all 2's. If I chose all 2's, I would get the mean as 2. But the difference between these values and the mean is nothing. So if they were all 3's, all 4's, the standard deviation would be the same. So the means are different. The first set has a mean of 1, the second set has a mean of 2, third set has a mean of 3, the fourth set has a mean of 4. But the standard deviations are the same, because that's telling us how things are spread out, and there's no spread here. Okay, for the next problem, can you choose 6 numbers with the largest possible standard deviation? So pause the video and see if you can come up with 6 numbers that you can think are there's the most spread that you can create away from the mean. Okay, so we want numbers that are as far away as possible. I believe this is the only example that has the most spread. Now, if we calculate the mean, we'll get, if I add up all these numbers, I'll get 15. And if I divide by 6, I think I end up with 2.5. So the mean here is 2.5. And you can double check. And look at all of these numbers. If I take 2.5 and I subtract it from each one of these numbers, I get 1.5. So the distance from the mean for all of these numbers is 1.5. Okay. Now, if I chose some other numbers, like let's say, I'm going to give you one, you can write it down. Let's say I chose 1, 1, 2, 3, 4, 4. Notice there's symmetry in this data set. So 1, 1, 2, 3, 4, 4. If you find the mean for this, you should also get 2.5. If I took this data set and I subtract 2.5 from each data value, with the 1 and the 1, I'd get 1.5. But when I subtract 2 and 2.5, I get 0.5. When I subtract 3 with 2.5, I get 0.5. So in this data set that I have, the 111,444, the difference from the mean in each value is 1.5. But with the other data set I gave you, not all of them are 1.5. Some are 0.5. So they're not as spread out. So this data set, the 111,444, it would have the largest standard deviation. It would be larger than the other set I just told you. Now you can come up with lots of different combinations, but when I'm looking at and how I figured this one out is I tried to think of something where the numbers were as far apart as possible. And the lowest number is a 1 and the highest number is a 4. And in between those is 2.5. And I cannot get further away from them. Like if I use 2 and 3, halfway is 2.5, but then I'd only be a distance of 0.5. So I want something that's really far away. This is a hard concept to grasp. So play with it if you want to try different combinations, but this should be the only set with the largest possible standard deviation. Okay, we're going to move on and we're going to talk a little bit about categorical data. Now, we talked about summarizing numerical data a little while ago. We talked about mean, median, mode, and everything I gave you were numbers and where all the mean, median, mode made sense. And we talked about bar graphs for numerical data. Now let's focus on categorical data, which we said are either words or they may involve numbers, but it doesn't make sense to average them, like to multiply and divide and do stuff like that. So here I have a data set. It's a spreadsheet, and I have different variables. And this is data on so there's a company called the Lending Club, and they have 10,000 borrowers. And they just took some data from each person, every borrower, such as whether they rent, mortgage, or own their house, whether they filed a joint or individual application, how old the borrower was, and how much money they made each year, their income. So maybe we want to summarize categorical data, something like application type or home ownership. You see that we have a bunch of data there. Like if we just focus on the variable home ownership, how can we summarize what's happening in that particular column? So we can also use a bar chart to summarize categorical data. When we work with categorical data, we usually call it a bar chart. When we work with numerical data, we call it a histogram. So what I can do, and I'll show you how to do this in a spreadsheet in the next video, but I can count how many people rent their home, how many people mortgage their home, and how many people own their home, just like I did in the other spreadsheet when we were looking at numerical data and I talked about college students and how many worked so many hours. I could sort this data. Now this data, rent, own, mortgage, it's not ordinal, right? It is nominal. And so it doesn't matter where the bars go. I could put own first, mortgage second, rent third. Doesn't matter. But I can count how many are in each category, and I can make a bar chart to show that information. So if the categorical data is nominal, the order of the bars don't matter. So we could rearrange things. With numerical data, we cannot rearrange. With categorical data, we can find the mode if it exists. So the mode, remember, is the piece of data that shows up the most. And in this particular data set, I haven't given you all the data. There's 10,000 pieces of data. But what I can do is I can count how many times rent shows up, shows up, mortgage shows up, and I can see which one shows up the most. And according to this bar chart, you can see the tallest bar is mortgage. So the mode of the data is mortgage. We can calculate the mode. For nominal data, you cannot find the mean and you cannot find the median. However, if you have ordinal data, you can find sometimes the median, but you will not be able to find the mean because we cannot add things up in categorical data. So let's look at this little spreadsheet here. I have students, sorry, I think I just have individuals and their ages and the highest level of education they've received. So the variable highest level of education, you can see there's high school, bachelor's, master's, GED, and so on. That is ordinal categorical data because there is a specific order that matters here. Usually GED comes before high school, and high school comes before bachelor's, and bachelor's comes before master's. We can still make a bar chart of this data. So we can count how many times GED showed up, how many times high school showed up, and bachelor's and master's, and so on. Now, I think there's more data here. So I don't think you can just, from what I've listed here, you can count all of them. I'm not sure. I think this originally came from a bigger spreadsheet. But anyway, you get the idea. You can go through and count how many times high school showed up and make a bar that shows you how many people had a high school education as their highest level of education, how many people had bachelor's and master's, and so on. The difference here, though, is this is an ordinal set of data. You wouldn't want to mix up the bars because GED is before high school, which is before bachelor's, which is before master's. And the high school is the mode, right? It's the highest bar. So it says that high school showed up the most um, in this variable. You can also find for ordinal data, sometimes you can find the median. So remember what median is. Median is where we sort the data from lowest to highest. Well, if GED is lowest and master's is highest, you can sort that data. We have 1 GED, 7 high school, 4 bachelors, and 2 masters for the highest level of education. So what I'm going to do now is I'm going to write this information on a piece of paper. I'm going to write GED once. I'm going to put HS. I'm going to write that 7 times. 3, 4, 5, 6, 7. Bachelor's, I'm just going to put the letter B for bachelor's. I'm going to write that 4 times. I'm going to write M for master's. I'm going to write that 2 times. I'm going to take just a second. I'm going to write this. I'm going to pause the video and then pull it up so you can see what I've done. We're able to find the median because I can write the data, GED, high school, high school. So I wrote GED once. High school, I've written 7 times. I have bachelor's 4 times and master's 2. And I'm just using B for bachelor's and M for master's. And like we talked about earlier, so what we would do is we would count how many pieces of data we have. Here I have 14 pieces of data. And if we add 1 to it and divide by 2, we get 7.5, which tells me we're halfway between the 7th and the 8th data value. Now, the median for an even number of data values like this, you can only find it if the numbers in between are the same, or the words in between are the same. So like high school and high school, the average of high school and high school has to be high school. So that's going to be the median. But if, let's say, you had high school and bachelor's degree, you don't have a median because you can't average high school. High school plus bachelor's degree doesn't make sense. Okay, so you can't have an average for that type of data where the seventh and the eighth are different. Now, if you have an odd amount of data, so let's say we had 15 pieces of data and it was ordinal, then we will always have a median. When we have an even number of data values, we may have a median. We might not, though.